Hi and welcome back to my latest YouTube video. In this video, I'm going to be explaining why a larger sample size is generally better in research. So let's assume you need to collect data from two groups of people. The first group of people have undergone treatment for depression, while the second group of people have not undergone treatment. We have three researchers here. We have Adam, John, and Trisha. Adam has enough time and money to collect data from all the 30 individuals. This is the entire population, by the way. John, on the other hand, has time and money uh, to collect data from only 10 individuals, whereas Trisha has time and money to collect data from 15 individuals. So let's go ahead and see what kind of results they get. We'll first start with Adam. So this is Adam's data set. Adam has, as I said, 30 respondents, and he carries out a test. Let's say he wants to compare those who have undergone treatment versus those who have not undergone treatment and their depression scores. So we go to analyze. We do compare means, independent sample t-test. We assume that the data is normally distributed for this example's sake. We choose the groups yes and no. That is, yes refers to they have undergone treatment, and no refers to the fact that they have not undergone treatment. Click OK, and then yeah. So when we look at the output over here, so this is Adam's output. You can see that there is a significant difference between those who have undergone treatment and those who have not. The results are significant at a very high level, and you can also see the significant difference in the mean score, which is 17.82. So those who have undergone treatment have a way lower depression score compared to those who did not undergo the treatment, right? So this is an example where we can clearly see that the treatment has worked. Now let's go to the other example. So now we're done with uh, Adam. We'll now move on to John. So John has a slightly different problem. He only has 10 responses because he doesn't have time and money to collect data from everybody. So what does John do now? So John carries out the same test. He goes to compare means, independent sample t-test, and he selects the treatment group. He does the same thing but with a smaller sample size. And what kind of results does he get? So the table below here, this is John's response, and you can see that although there is some difference here, the results have not turned out to be statistically significant. So because of this, the John may have a completely different conclusion. He may draw a completely different conclusion, which we'll get to later. But this is the result secured by John, and these results are not statistically significant. We then move on to the third researcher, who's Trisha. So this is Trisha's data set. Trisha could not get all 30 respondents, but she was able to get 15 respondents. So what kind of results does she secure? We go to analyze, compare means, independent sample t-test. So Trisha is the same thing. Okay, so define groups, yes, no, click continue, click OK. So when you go to the output, you see that this is Trisha's, the one at the bottom. You can see that there is a significant, there's a difference between the mean scores, and the results are statistically significant at a 0.05 level, which is a moderate level. Though it's not a very high level as in the case of Adam, it's still significant, and this does help Trisha get to a conclusion that is more accurate than let's say John. So we'll move on to the conclusions that each of these researchers have secured. Adam's conclusion is that there is a statistically significant difference between the depression scores of both groups, with those who have undergone treatment having a lower mean score of depression. Thus, the treatment works. The null hypothesis is rejected. So Adam's conclusion, of course, is obviously accurate because he's taken all 30 respondents. John, on the other hand, he comes to a wrong conclusion. Essentially, there is no. He comes to a conclusion wherein he says that there is no statistically significant difference between the depression scores of both groups. Thus, the treatment does not work. So this is a wrong conclusion, right? Whereas Trisha comes to the right conclusion, even though she uses a slightly smaller sample size compared to Adam's, hers is slightly bigger than John's. That's why she comes to the right conclusion, and she says there is a statistically significant difference between the depression scores of both groups, with those who have undergone treatment having a lower mean score of depression. Thus, the treatment works. So Trisha's sample size was slightly larger than John's, and you can see the difference it's made in terms of the final conclusion. So, what do we learn from this? We learn that a larger sample size helps us secure accurate results. Okay, a bigger sample size is always better. Secondly, a larger sample size helps us avoid type 1 and type 2 errors. Right. So problems like false positives, are avoided when you have a larger sample size. So I know time and money is always a constraint, but as researchers, we must try to ensure that we always have a large enough sample size so that we can accurately test the hypothesis and come to the right conclusion. I hope you found this video useful. If you did, please like and subscribe to the channel for more such videos. Thanks for watching, and bye for now.